a couple more examples of being able to work with our improper intervals. We have 3 to infinity sine pi over x dx over x squared. Clearly, this is just going to be an infinite discontinuity. And so we can just make the limit as c goes to infinity as our upper bound. So lim as c approaches infinity, 3 to c of sine pi over x dx over x squared. All right. Now, this is going to be able to evaluate the integral. It's a u substitution. All right. We're just going to go ahead and let u be equal to what's inside the parentheses. So u is going to be equal to pi over x, which is the same thing as pi x to the minus 1. That's the derivative is going to be minus pi x to the minus 2 dx. And that helps us a lot because we have an x squared in the denominator and an x to the minus 2. We could just divide by negative pi. And so negative du over pi is going to be equal to 1 over x squared dx. And that gives us precisely what we need. So now we're going to go ahead, substitute. So we're going to get our limit as c approaches infinity. And we're going to have the integral. I'm just going to go from a to b. We have sine of u. And then we have negative du over pi. Now, the good news is the antiderivative of sine is negative cosine when we evaluate it. And then this negative is going to go away. We can pull the pi out. So after we do a few computations, we're going to get the limit as c approaches infinity of 1 over pi times cos of u from a to b. Okay. If we back substitute for u, remember we said that u was going to be 1 or pi over x. So now we get the limit as c approaches infinity of 1 over pi times cos pi over x, and our limits were from 3 to c. All right, so right here, we're going to substitute c, we're going to substitute 3. So now we get lim as c approaches infinity, 1 over pi cos of pi over c minus 1 over pi cos of pi over 3. All right. Now, be careful with this, all right? Because what we're going to do is we're going to substitute infinity back in for c, and that just makes it pi over infinity, which is 0, but it does not zero it out, okay? So what this becomes is 1 over pi cos of 0 minus 1 over pi cos of pi thirds. And that's where we need to go into our unit circle, and we need to look at the x coordinate, since cosine is our x coordinate on our unit circle, and we're going to look at 0 and pi thirds. Cos of 0 is going to be 1. That one's pretty easy. Cos of pi thirds is going to be a half. And so this just becomes 1 over pi minus 1 over pi times a half. All right. If we get a common denominator of 2 pi, this becomes 2 minus 1 over 2 pi, or 1 over 2 pi. All right. And of course, we want to verify this if possible, because it's not always possible using Wolfram Alpha. But let's see what Wolfram Alpha gives us if we try it. All right. So I think I closed it out because it gave me an infinite loop on my last problem. Right. And so we want to integrate our sine of x over pi, or pi over x, with, divided by x squared with respect to x from, I think it was 3 to infinity. All right. And it might give us the answer, it might not. All right. But it looks like it gives us 1 over 2 pi. And I believe that's what we got, 1 over 2 pi here. All right, so that's good. And again, it doesn't necessarily matter what the answer is. It matters about the process as to how we do this. Okay, so hopefully that makes sense to everybody, especially with this tricky limit right here. Okay, being able to evaluate the limit as c approaches infinity of cos of pi over infinity. Right. So we'll do our last problem in our next video, just because I think our last problem is going to take us a little bit longer than some of the other ones.